In the beginning, when dinosaurs roamed the earth. Okay, well, not that far back, but long time ago, like cavemen and saber-toothed tigers and those big bushy elephants called mammoths? Not that far back either? Well then, how far back are we talking here?
I guess only 6,000 years ago, when the first astronomers ever, the Mesopotamians, came to Broadway, they were like the timekeepers of the region. They used these pyramid-like towers with 7 terraces called ziggurats. This represents the celestial bodies, the Sun, Moon, Mercury, Venus, Mars, Jupiter, and Saturn, and would be stood upon by the astronomers to observe the movements of the bodies. Unlike the Mesopotamians, the Egyptians used astronomy for more practical purposes, such as a calendar to predict the flood of the Nile and somehow align temples and monuments. The temple and monuments were used to line up with the cardinal points north, south, east, and west. Sadly, no records have been recovered to tell us poor future humans how they did it.
The Stonehenge was believed by many that it was used to predict astronomical events. It also was built to align with the position of the summer and winter solstices. Long ago, as far back as the 13th century, the Chinese have made and recorded observations of eclipses. Enough records have been recovered to tell current astronomers that 900 solar and 600 lunar eclipses were recorded 2,600 years ago, give or take. The recorded conspicuous astronomical events like meteor showers, guest stars, or exploding stars and comets helped Chinese astronomers to determine the length of the year, discover precession, as well as predict when eclipses can occur.
In Theo's time, he became the first to predict a solar eclipse. Most didn't think it was possible for Thales to predict the eclipse. Historians think perhaps he heard of the 18.6-year cycle of lunar eclipses and mistakenly applied it to solar eclipses. If that's the case, he sure had luck on his side. Pythagoras developed the model for a solar system. Luckily, he was pig-headed enough to reject the idea that everyone else had of the Earth being flat and acquired some male parts to originate the idea of the universe consisting of spherical bodies moving in perfect circular paths.
The Babylonians were able to use the long record of observations to see patterns in the motions of the moon and planets. They then determined dates for the moon, sun, and planets to find their synodic period, which is the time needed for the planet to go from a particular configuration back to that same configuration. Hipparchus is known for discovering a new star, but mostly for developing the earliest systematic catalog of the brighter stars that could label the positions and indications of brightness for 850 of those stars. He also discovered precession. The last of the great astronomers of antiquity, Ptolemy was known for the completion of the solar system model that could accurately predict the motions of the planets using a combination of regular circular motions. The Arabs were the leaders in math and science and already had given most of the stars names we still use today before anyone else. Since they lived out in the desert, they relied heavily on stars, mostly for timekeeping and determining latitude and longitude for navigational purposes. Copernicus proposed the first fully redeveloped heliocentric model of the solar system. The only thing wrong with his model was the motion of the planet's epicycles. Instead of the planets revolving in ellipses, his planets revolved in perfect circular movements.
Newton discovered the law of gravity. He found that the moon is held on an orbit by force of the gravitational attraction of the sun and earth.
What made Tycho Brahe known was the book he wrote describing his observations of the nova. He later set up a shop to build astronomical instruments out of metal, which gave him the upper hand of accuracy in his observations.
Einstein revised Newton's law of gravity to make it more accurate. Niels was a physicist who made contributions to understand atomic structure. Niels received a Nobel Peace Prize for this.
In Galileo's time, he enhanced the telescope, and with it made unforgotten discoveries such as Jupiter having moons. He discovered Venus, the sunspots on the sun, and the geography of the moon, such as the mountains and its plains. Kepler, who was Brahe's assistant and student, used his teacher's extensive collection of astronomical records to develop 3 laws of the planetary motion. Wolfgang Pauli contributed to the discovery of Pauli's principle, which involves the spin theory, in other words, the basis of the structure of matter. Werner Heisenberg was a theoretical physicist and a key creator in quantum mechanics. He also put together the brilliant idea of the uncertainty principle. Edwin Hubble discovered the Doppler shift, or Hubble's law, in other words, that far away galaxies are moving away from us. The law states that galaxies recede from each other at a rate proportional to their distance from each other, aka the cornerstone of the Big Bang theory. Hubble also created the Hubble telescope. Georges Lemaitre was a professor of physics and was known to academically propose a theory of the Big Bang model. He was the first to derive Hubble's law by proposing the Big Bang model. Robert Oppenheimer was considered to be the father of the atomic bomb, but when he realizes the power of the bomb, he wants nothing to do with it and goes on to studying neutron stars. Fred Hoyle predicted that a form of carbon-12 can be produced within stars. Later, Hoyle's theory was proved correct by someone named William F. Arno Penzias and Robert Wilson were the co-discoverers of the cosmic microwave background radiation, which supposedly is left over from the Big Bang. Neil Armstrong and Buzz Aldrin are known for the first ones to go to the moon.